Sup guys, welcome to today's show. So today we're gonna code something interesting, and we're gonna code a curses library. And most of you are familiar with how a console works. So if I print something like hello and another hello, and this is the same as if you do printf in C, then it just adds the line next to below the other one. But what if you want to change the first line? Then you need to clear the screen and print it all over again. And that's one of the things that a curses library is trying to solve. Another one is when we read something. When we read something, we read it from the keyboard like this. So it waits until we press enter, and then it presents the whole buffer to us at the same time. And that's all good and well, but sometimes you need a little bit more granular control. What if you want to control, let's say, some kind of cursor on the screen with your arrow keys, or for some other reason you want to get access to each individual character as they are typed. Well, similar to like the VI text editor. Here we can move around and we can add stuff, and maybe we want to create our own text editor. Then we need a library like this. And one way of doing this is by using the ncurses library in C. The original curses library is for the Unix systems, but I'd say ncurses is more widely used today. And it works similarly to this. I don't remember the exact commands, but something like init window from the beginning to initialize things. And a window, by the way, in this context is a full screen window that you can shift between. But so like if I create another screen like this, and then I can toggle between them. So that's basically the same thing. Alright, so we initialize the window, and then we can use, for instance, fgets. And this will read one character from the keyboard. And it doesn't matter if it's like a letter or if it's an arrow key, it will report it either way. And you can also do stuff like echo, I'm not sure how it's done, but echo 1 maybe, to enable echo. So the characters are shown on the screen when you type them, or you can echo off. And when you print something to the screen, then you can use, for instance, get xy, I think. And you will get access to the x and y coordinates of the screen. And you can also use move to change those coordinates. And then you can do print, it's not printf. What do they call this? I think it's print W. And this will print something to a specific window, at this location, so you can print stuff wherever you want it on the screen. Okay, so I want to build something like this to give us more granular control, and with this I will be able to code my own text editor, which definitely will be a later project, and also my own bash shell like this, because here we don't just want to type in commands and stuff. We also want to be able to use our arrow keys and modify the input and stuff like this. So for both of these things we need a cursors library. We could use the existing ncursors, but you know me, I want to code it on my own. So I have started out with a template created by bashbs, and you can download bashbs as well as my birch utils library. Here it is, and you find it on this repo. So that's all you need for this, and as you can see, it just creates a very simple C template, a make file, and a slightly more involved .h file, which basically just imports birch utils and some other stuff. It creates different integer types, int 8, int 16, and so on. And then we have the reverse. So these are just macros for typecasting. And I want to change these, so it's 1 byte, 2 byte, 4 byte, 8 bytes. Also, I'm using C2X here by default. If you're running a slightly new GCC, you should be able to do C2X. If you run the absolutely latest version, 14 point something, you can even do C23, which is what I'm going to do. And if you run an older version, just delete this. Alright, so this should compile at its current form, and it doesn't do anything. Okay, so how do we structure a project like this? That is the question. I think I'm gonna start, as usual, by defining the data types, and then we only need to define the functions that use these data types, and then we're done. Simple, eh? So let's start with the window. So I want to support multiple windows, at least full screen windows, perhaps even real windows or something similar to real windows. But that will come later. For now, at least full screen windows. So let's define a structure for that. So we'll have a struct s window. And a window needs a vertical and horizontal size, right? So what should we call that? Rows and columns, perhaps. So let's see. Do we need to support something bigger than an int 8 here? Let's check this terminal. This is rather big, right? So let's see how big the cols and rows are in this case. Columns, perhaps. There we go. 91. And the rows columns, row, what's it called? If we do set and we grep -I row, lines perhaps. There we go. Okay, so this is 91 times 27. I think we will get away with a maximum of 255, right? So int 8 calls int 8 rows. So that's going to be the vertical size and horizontal size for each window. And for the actual screen, because the screen itself will be the root window in this design. Alright, so what else do we need? I guess each window should have an identifier, or at least a number of some kind. So let's say we have an int 8 ID. And if we're going to support smaller windows than the entire screen later on, we will probably want to have some kind of title bar. So let's make room for that even now. So let's say we have a title, and this can be, I don't know, 16 bytes perhaps. We can modify this later on if we need to. Alright, and maybe we should define if this is the active one as well. Or maybe we even should have some kind of ordering between them. Well, we can add the ordering later. Let's just have a boolean which is active, yes or no. Okay, so that's that. What else? Well, we need to have a frame buffer, right? So frame buffer fr. And what is a frame buffer? Well, that's the entire contents of this window in a long one-dimensional array. And this will be chopped off. So it will be divided into cols and rows before it's printed. But this is where we put all the stuff. So we need to define what a frame buffer is. Let's just say that this is packed, which means that we are not leaving any room for alignment. And we'll type def our struct s window to window. And we need to define packed. So packed is going to be an attribute. And I always forget if we need those afterwards as well. I don't think so. Like so. Alright. And what is a frame buffer? So let's see. How should we define the frame buffer? Well, what should it contain? It will be an array of something. I think I will have an array of 16-bit values, because then we can have the actual contents of that byte, like a letter, and some coloring info and some other stuff perhaps. So let's do it like this. We'll type def unsigned char as frame buffer, and then we can make this into a pointer, like so. Alright, so we need to add a few more things. We need to have x and y coordinates for the current position of the cursor. So let's just create an int 8x and int 8y. And I think I'm gonna add one thing to this frame buffer. So instead of defining it like this, let's say we do it like this. So we type def an unsigned short int, and this will be one point in the frame buffer. So it's not an entire buffer of frames, I guess it's just a frame. And then I'm going to create a structure, because I need two things in this frame buffer. So this is our frame buffer. And first of all, we need to have an actual frame buffer. So this will be the, let's say for FB, for frame buffer. Then I want to have a bitmap. So let's say we have it's going to be an array of booleans, but I think I'm going to do it as a pointer. Let me see. Maybe we don't need to allocate everything like that. So perhaps we could just do bool and make an empty sized array of this. So this is going to be the bitmap, like so. Right. So let's also make this packed. And let's type def our struct s frame buffer as just frame buffer, like this. So the general idea is we fill this frame buffer with the data that we want to have on the screen. And when we change things on the screen, it's not going to update directly, but the change will be contained in this frame buffer. And this bitmap, this will just be a long list of booleans where each single bit corresponds to one frame. And if it's a 0, then it has not changed. And if it's a 1, it has changed. And then we will run an update function, which will update all the frames indicated by this bitmap. That way we don't need to update the entire screen, so it'll be flickering and stuff like that. But instead we will only update the actual frame, which will be more optimized, and it will look better as well. So let's see, this should be a frame buffer like this. So do we need to have one for the old one and one for the new one, or do we only need one? I think we can get around with just one, since this bitmap will take the other stuff into account. Alright, so this public API will have a whole lot of different functions, but I think I'm going to just do one at a time so we can see what happens. But first of all, we need to have constructors. So we need to have a constructor function for a window and for a frame buffer. So we will have a frame buffer make frame buffer. And this is not going to take any arguments. And we need to have a window make win. And this needs to provide the size of the window at least. So let's say we do let's say we have two int 8s, one for the columns and one for the rows. And maybe we should define the title at this point as well. So let's just have an int 8 star for that. Right. Let's start there. So let's make it easy for ourselves. Let's copy this thing. But we need to know the size of the frame buffer. So we need to give that as an argument at least. So let this be an int 16, indicating the number of frames in the frame buffer. So basically the columns times the rows. Okay. And maybe we shouldn't have the same variable name for both of these. This is the actual frame buffer. So what are these? These are the frames, I guess. And when we know this, the size of this thing, the number of frames, we can easily calculate the bitmap, which will be the same amount, but half of it, and then divided by 8 to turn it into bits instead of bytes. Well, I think we can start to create this thing. By the way, I want to define, since this is going to be a public library, we need to define some export and import stuff. So first of all, let's say we have an export, which is going to be an attribute, and this attribute is called visibility, I think. Visibility. And the visibility is default when it's exported. And we also need to have something which is, let's see, not private but protected. And same here, the visibility is going to be hidden in this case, so this will not be exported. And let's also have a private, and this will have this attribute with the visibility hidden as above, but this will also be static, which means that it will only exist in the file or the translation unit. Okay, so now we can define those. The frame buffer will never be created manually by calling this function. So this can be protected, maybe even private actually. But creating a window, that needs to be a part of the public API. Like so. Alright, so let's start with this thing. So we're going to have a private make frame buffer, and we need to have an int16 with the number of frames. Let's call this num. So I guess we can assert that num is more than 0 at least. And we need to have some variables. We need to know the size in bytes. We need to have a frame buffer pointer. And we are also going to create the bitmap at this point. So we need to have a bitmap pointer, bm. And let's start there. So maybe we should create two sizes actually. So let's do it like this. So we're gonna have a frame buffer size, and we're gonna have a bitmap size. Yeah. So let's see. We also need to allocate this separately. So in addition to all of this, we also need to have a frame size. frame pointer. Alright, so where do we start? Let's start by defining the frame pointer. So we need to calculate the size. So the frame size is going to take in is going to take in the well, let's do size of frame times the number of frames. So that will be the size. And now we can do frames is equal to frame malloc. This will be the integer of frame size. We can assert that we have an FM. Alright, so that's one thing. And we need to calculate how many bytes we need for the bitmap. But we don't actually need a pointer for that, since we have this array here. So we only need to take into account when we allocate for the structure. So let's actually remove this bitmap, but we need to have the bitmap size though. So let's see. We need to take the number of frames let's say, and then we need to divide it by 8, and we also need to have some kind of parity, because if if this division ends up with fractions, we need to round it up. So basically we need to do something like parity is equal to num, and then we take the modulus 8. And if this is not 0, it means we have fractions, so then we want to add 1 byte. Otherwise, we don't want to add any bytes. Which means that we can do this calculation and just plus this eventual parity. And then we have enough room for this thing. And now we can calculate the structure itself. So we take the, let's see, the frame buffer size is equal to the size of a struct S frame buffer. So that's the structure. What else do we need? This includes this pointer, so we only need to add the size of the bitmap. So let's do that, plus bitmap size. And now we can allocate for this thing. So the frame buffer is equal to frame buffer make the integer of the frame buffer size. We can assert that we have an FB, and now we just need to puzzle all these together. By the way, when we have created, let's see, when we have created the frames, we want to zero out the frames. So FM, and we give it the FM size, and same here with the actual structure. We want to zero out the frame buffer with the frame buffer size. And now we only need to link this pointer, and then we are done. So we're gonna set the frame buffer frames, I think we called it. FB is a frame buffer star, frame buffer frames, yeah. So we set frames equal to our FM. And now we can safely return the FB. Okay. So now we can create the frame buffer. Now we need to be able to create this thing as well. So let's copy this stuff and paste it in as comment. We can remove some stuff. And the ID, how will we handle that? Because I will want to try to avoid having global variables as much as I can. I will, however, have some kind of a state structure where we collect everything that needs to be global, and then we can pass that structure to whatever we need. So let's create that. So let's say we have a struct s state, and this will be quite small now at the beginning, and then we will increase it when we need more stuff. But for now I only want to keep track of the IDs. So let's say we have an int 8 next ID. And let this be packed, and we type def this as well. As state. Which means we need to have a make state as well. I'm not really sure how I'm gonna deal with this, but for now let's make this public. So make state, and this will not need anything, I think. Or do we need to keep track of the actual... Well, we can have the root window right here. So let's say we have a window root, which means we need to move this down a little bit. So we have the window defined before this one. And if we do it like this, then we don't need to have anything here, because as soon as we create the first window, we will put it inside of here, and then we know that the root windows, columns and rows, that's the actual screen size. So let's create this constructor, and this will be very simple. We will just do something like this. Public state make state, and we need to have a state st and an int16 size. Size will be size of struct s state. State will be equal to this malloc of size. We can assert that we have a state, and then we can zero out the state with size and return this state. Okay, so this will mean this next ID is 0 from the beginning, which is good. Maybe we can even make that explicit, so we really show our intent. So st next ID is did I make it an int date, or yeah. So let's just do this then. Alright, so now we can create this thing. So we're gonna have a public, it's gonna return window, make window, and we need to have the calls, rows, int8 title. So let's assert a couple of things. That calls is not 0. Same with the rows. Same with the title. We need to have a window win. We need to have an int16 size. Size will be, let's see. Yeah, we can just define it like this. So it's going to be the size of a struct s window. We can assert our, no, not yet. First we need to create it. All of these constructor functions are pretty similar in nature. Maybe I should create some make constructor or something. This will be the size. Then we can assert that we have a window, and then we want to zero out this entire thing. So win size. Alright, so what do we need to change inside of this thing? The ID should be taken from the state, which means we need to provide the state as well. So state st. Let's update it here so we don't forget. Alright, let's move this down a little bit. Okay, so our window ID is going to be the state next ID, and then we want to increase that next ID. X and Y. Set both to an explicit 0, so it'll be by the top left corner of the screen. Columns and rows, we need to take let's see. Oh, we can take it from the arguments, that's right. Or the parameters. So the win calls is equal to calls, and the win rows is equal to rows. The title we need to copy from this. So let's say we have a string copy function, which we'll create later, but for now I will just do some temporary stuff. So let's say temp functions. So I'll create an alias. Later we will create a real function for string copy, but for now we can cheat and use the standard C library stuff. So string copy, we need to have a destination, we need to have a size, and we need to have a source. String copy to destination with size and source, and let's put all of this in parentheses in case we want to have an expression here instead of like a variable or a constant, something like this, so we don't have to worry about that right now. Alright, so we have a string copy, and our destination is going to be the win title. The size is going to be 15. And the source is going to be the title, the parameter that we have right here. Okay, so now I have taken all of these into account. And active, well, that depends actually. If this is the first thing, so if the win ID is 0, that means that this is the root. In that case, we want to set active to true, and And we also want to go into our state and set our root equal to the window. Otherwise, we just want to set the win active to false, because it should not be active by default. We should be able to create windows without showing them on screen until later. And now we only need a frame buffer. So our window frame buffer is going to be equal to make frame buffer. And did it take any arguments? Right, the number of entries. So let's create a variable for that in 16n. And let's see. We can do something like this. Let's set the n equal to, and this will just be calls times rows. Then we can make fb with n. And let's double check that this win frame buffer really returns something. If not, we need to free our window. Return window 0. Otherwise, we are done. So we'll just return the window. Okay, so now we can create all our different things. What is the logical next step? We need to be able to deal with this bitmap somehow. We need to be able to set bits and get bits. And I think we can just create some macro for that. So let's see. If we wanna, let's read a bit from, so get bit, and we need to know which bitmap it is. So let's say we have VM here, and we need to know what bit we're talking about. So let's say bit. And what are we going to do? So the bit can be a rather large number, because it's going to take into account all the different bits inside of that thing. So let's start by finding the right byte to deal with. So bits divided by 8 will take us to the correct byte. And we also need to, let's see, we also need to know what the modulus is, because if we get to the right byte, we still need to get to the right bit inside of that byte. So maybe it will be easiest if we just do this. We need to go to this bitmap and we index into that like this. And in order to grab the correct bit, we are going to need to AND this thing with something to get to that specific bit. And we need to AND this with a 1, shifted left the number of bits inside of that byte. So here we need to take the bit mod 8. And when we have selected that specific bit, we also need to shift it to the right, so we get that bit at the rightmost position of this byte, which means that we need to take this whole thing maybe jump down one line. So we need to take this whole thing and then we need to shift it right the same number of times. So bit mod 8. And then we get to the correct bit, I think. Maybe we should test this. By the way, I want to parenthesize or maybe that's not really necessary in this case. Perhaps the bit can be parenthesized in case we need an expression to figure out that bit, but the bitmap will always just be a variable. So a lot of parentheses here, right? But I think this is going to work. How can we test this? Let's create an int 8 and let's say, or let's create an array of booleans instead. So let's say we have 16 booleans. So this is our bitmap. 16. And let's zero initialize it to make it easier. Maybe we need to do this actually. we'll have a single boolean, which is our bit, and this is where we want to store the result. So let's start by setting one of the bits. So let's see, BM let's say the 14th bit is going to be true. Let's explicitly set 13-bit equal to false. And let's say our bit is equal to get bit. And we provide our bitmap, and we want to grab at the 13th bit. And then we can print it out. It is equal to this. Something like this. So now we should get a 0 if it works. Let's see. Hidden undeclared here. Maybe it's not called hidden. What can it be? Visibility, default visibility, invisible, perhaps? Invisible. Same here. I think we need to Google for this actually. So let's see, if we search for GCC function attributes visibility, DLL export, DLL import, default hidden. Okay, we need to put it in quotes, that's why. We were right the first time though. See, visibility attribute ignored. Let's deal with that later. Unknown type, name, public. Didn't I add public? Okay, I named it export here. Maybe we should say public instead. And it seems like a whole lot of errors here, but usually if we fix just a couple, the rest will go away. Type defaults to int in declaration. Oh, I forgot the data type. So public state, make state. How did I do here? Public window, public state. Okay, that's right. Return type. Oh, I did it wrong here. Private make FB. Private frame buffer star make FB. Now these should be the right thing. Zero makes point from integer. Okay, this is line 25. This should not be $I, this should be 1. Let's check the other zeros. This is right, this is right, this is right. A lot of small annoying errors, but I guess that's better than those that take ages to troubleshoot. Expected expression before state. That's right, it's called ST. So where is it here? So the data type is called state, but the variable was called ST. Pointer targets in passing, different signness, that's right. So let's fix that. In our string copy, where is it? Here. So win title is an int8 star. We need to make this into a regular char star. And same here. It's good to have those short aliases for typecasting because there's usually a lot of it. And same with the size. All those signness stuff. So this 15. Was it that one? Let's double check. So, okay, this is line 3rd, no? Size. The order. I always forget about the order when it comes to string copy. So this should be the S, and this should be the size. And now they're all gone, almost. Window has no member named, frame buffer. Okay, what do we call it? FB perhaps? Yeah, that's one. So when So the visibility is ignored when we use private. I guess that's because we use both static and the visibility hidden. So static takes precedence. Alright, so now it should compile without any warnings or anything. Let's see if we get a 0 bit. Okay, bit is 0. What about if we use the other one, the 14th or whatever? Yeah. So bit is equal to 14. And now we should be getting a 1, right? We don't. We don't. Let's loop through all of them, because then we might be able to detect why this happens. So let's create an N, and for N is 0 and less than 16 and plus plus. We need to do this. And let's also say what bit it is. So it's this. Something like this. All of them 0. I don't like that. Let's skim through our code here. So let's say we want the 14th bit, right? So the first calculation, bit divided by 8, is going to be 14 divided by 8, and as an integer division this will be 1. And the modulus operation is going to be, let's see, so 1 times 8, and then we have 6 more. So something like this. So we're going against BM indexed by 1. So the first byte. Wait a second, maybe it's when we do those booleans, maybe it allocates a whole byte per boolean. I guess that is entirely possible. So how do we deal with that? Can we do a bool pact perhaps? Does that that even compile? Ignored. Let's define this as an int 8, 2 instead. So 2 bytes. And let's call it something else. Let's say this is the data. And then we're going to have a pointer, which is a bool. So bool bm. It would have been easier if we had our set function, because I guess this would probably be the same. But let's see what we got. So if we have 2 bytes, we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So these are our bytes. And byte number 11, or bit number 13, we have 8, 9. Let's see, it's 0 indexed. So this is number 7, 8, 9, 10, 11, 12, 13. So this should be a 1. And this is 1 position, 2 position, 4 position. So basically we can set the first to a 0 and we set the second to a 4. But let's see, 13. Okay, so the 13 position, 15, 13, 15, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this we want to have a 0, but this we want to have a 1, right? So it should be 0 and 2, and then we can comment these 2 out. And let's see what happens. BM is initialized. I didn't point it towards them. Well, let's do this. Bit 9 became a 1. At least we're a little bit closer now. Bit 9. Okay. So that has to do with where it has to do with what's it called? Big endian and little endian. we go into this, take the 1 and we push it this number of times. Okay, so I counted from the wrong order. So here we have bits. This is bit 0 and this is bit 7. And this is bit 8, 9, 10, 11, 12, 13, 14. So here we should have the 1 and not here. And what does this become? This is 1 position, 2, 4, 8, 16, 32, 64. So I coded the right function, but I used it the wrong way. And now I believe it should work. Yes, it does. Okay, nice. So let's create the set function. It will be pretty similar, I guess. So define set bit. Gonna have a bitmap, bit, and like before, we need to have our bitmap, and we will index into it by taking the bit number divided by 8. So here we have 1 parenthesis, here we have 1. This should be here. Okay, so this is our byte, the correct byte. So let's see. We need to handle this a little bit differently if we're going to set it to a 0 or a 1. So let's start with a case where we're going to set it to we're going to set it to 1 because that's the easier one. So BM should be ORed and equal and now we need to do basically the same thing. We need to take a 1 and shift it. We take the bit and OR it with, modulus it by 8. So this is the bit number inside of the byte, and this is the byte, and then we just OR it with 1. So let's say this is our set bit. And maybe we can have a different alias for unset bit so it becomes a little bit easier to handle. And in this case we need to to do an AND operation. And we need to take this, but we need to take the inverse of this. Something like this, I guess. I'm not entirely sure though. Let's see if it works. So let's set all of this to 0. And let's see if we can set bit number well, any really. So set bit of BM, and let's say we want to set bit number 3. And let's also say that we want to set bit number 9. And then we want to unset bit number 9. So if we have coded this correctly, then only bit number 3 should be set. It works beautifully. That's pretty nice. Not the easiest macros to just figure out in the head, but I have done similar stuff a couple of times, so that's why. And if you need to, if you want to know more about this stuff, which you should, because it's very useful. I almost use it in every project in some way. Check out my episode, which is called Binary Operations. There you will learn all about this bit level stuff. Okay, so now we have prepared all of this. Let's also create some kind of initialization function. So let's say we have a public void init. Maybe we can call it init library. We don't need to take any arguments, I think, or do we now? It would be kind of nice to pass the environment somehow, but I don't think that's possible. So let's say this is void for now, but we need to make sure that it runs when we start the load the library. So how do we do that? We need to use some kind of attribute for that as well. So let's say we call this init or something. This is an attribute, but I'm not really sure what it's called. I think it's called fini for the opposite when it unloads. But what is it called when it loads? Let's see. GCC attribute. Yeah, GCC function attribute. And let's search for fini, and maybe we can find the other one as well. Maybe it's not called fini. Let's see. Pure const, no throw. Maybe it's constructor that I'm looking for. The constructor, blah 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 blah, function to be called automatically before execution enters main. Doesn't say much about libraries here, but I think that's the same thing. So constructor. Let's go here, and we have a public init library. Let's try something like this. Oh, I forgot the return type again. Public init void. Huh, that's pretty cool. And this should work even for libraries. Okay. So what do we want to do inside of this thing? I guess we want to create the root window. And this global state object. And I'm not too fond of global variables, but I'm not sure if it's possible to do this in another way. So let's say we have a state, global state, and this needs to be public. So inside of our initialization function, we will set global state equal to make state. And did it take any arguments? No. And maybe we don't need it to make this public then. We can actually make this private, since it will be called inside of our initialization function. And we should never be need to create another state object in a different scenario. So let's make this private like so. And let's also create the root window. So let's call make window, and what arguments do we have here? We pass the state object, and then we have calls and rows and the title. So which order of these calls and rows? First calls, then rows. So we pass the global state object, and let's see what we should use for now, at least. Later I'm gonna take these from the environment somehow. So lines, that is how many rows we have. Columns, so let's say we have 90 times 25 or something, just as an example. And let's say this is the root window, like this. And we don't really need to do anything with this return value, since it's going to be saved inside of this global state. So let's just do this. Maybe even like this, so it will not be optimized away. Right, something like this. Maybe I did it in the wrong order. Should it be void volatile, perhaps? What about volatile void star? Weird. Maybe I can only use that when I declare stuff. Well, let's skip that for now. And let's just do this. It does not like that, actually. I'm pretty sure I have used this before, but then I guess I used it with a variable, and here we have a function. And what if I just call this like this? Then it would probably complain about the return value, I guess. Oh. Did I have... I forgot the semicolon. That's why. Alright, so volatile void. I thought it was weird. I think it should have worked, but okay. That's better. And does it still work? Yes, it's loaded. So now it automatically does all these things. Pretty nice. Let's remove this loaded, and we don't need to have... We're not going to have a main at all, actually, since this is a library, but it's good to have it during development because it makes things a little bit easier to deal with. Okay. Alright, so now we have set up all the different stuff. The basic stuff. And in the next episode we are gonna create so we can print things to the screen, read from the keyboard, one character at a time, well, possibly adding some function to read until enter press as well, and update the screen according to this frame buffer and dealing with color coding and all that good stuff. But at least we have started the project and gotten a bit on our way. So I hope you like this episode, and this is going to be a great project, so don't forget to hit the bell icon and subscribe. And thank you for watching. Thanks for today.